I'm here to give you more information about the Sharp Vision Otdr AS915. This AS915 is not only an Otdr, it is 6 in 1. We mentioned it correctly here. There are 6 parameters which you can measure with the help of this Otdr. These parameters are not only Otdr, it's an optical power meter, it's a visual fault locator, it's a optical source, it's an optical loss meter, and besides that it is also a RJ45 tester. So now I'll go in a little detail about the functions of the various ports. I'll describe the various ports also. Of the Sharp Vision Otdr is to check the faults in the fiber network which you have spread out, poorly connected connectors, bending losses, and total length of the cable. Sharp Vision Otdr can measure number 1 for fiber optic power. In fiber optic power is measured in dBm, which is called as the absolute power. Just for information, 0 dBm is 1 milliwatt, as you already know about it. Then second is VFL, visual fault locator, is useful for finding the faults in the vicinity of the Otdr, because in all Otdrs have a dead zone of say about 20 to 30 meters where Otdr cannot measure, cannot take proper readings. So VFL takes over for the various faults due to kinks, due to bending losses, due to bad connectorization. Then we have an optical laser source. There are 2 sources, one is 13 and 10 nm and one is 1550 nm. Both the fiber cable can be tested with the help of these 2 laser sources as per the customer's requirements. Then we have an optical loss meter to provide the accurate end-to-end insertion losses. RJ45 cable tester I have already described. For testing RJ45 cable, we have a remote unit along with the Otdr. Now what all accessories we are providing, I will go into that detail. Besides the Otdr, there is a carry bag. There is a carry bag, and I'm taking out this Otdr to facilitate to you, to let you know the various details of the Otdr. We have a RJ45 cable, the remote unit for RJ45. Then we have cleaning buds. One is SCAPC, which is fitted on the, already fitted. Then we have SCUPC connector, which is called a hybrid adapter. If your network is finishing with the green connector, we can directly insert into this port of Otdr. If it is a blue connector, then you have to insert this hybrid adapter, insert करके दिखाओ, so that you get the correct readings in this. Battery charger for charging the battery, which is at the back, connected at the back of the Otdr. Is a battery charger provided. The ports of the Otdr. Main port is Otdr port, which I have already described. We use a hybrid adapter along with this for measurement of the fault, for finding the faults in your network. Then we have a VFL port. I'll switch on the VFL port to let you know. The VFL port is there. We press the laser source on the screen, VFL's the screen, and we get the laser VFL output. Then there are 3 frequencies in this. One is 1 Hertz, then is 2 Hertz, and one is normal for the continuous light. Now next is OPM meter, optical power meter term in the port. We are connecting one Sharp Vision transmitter and we are doing the measurement. I is showing the power. It's a long press by which it will switch on. The screen shows various touch buttons which shows the various parameters it can go into. The first one is touch auto OTDR button, and we touch the auto OTDR button. The display here shows 1310. We can change over to 1550 and again go to 1310. We are now testing at 1310 nanometer. Then now we take the time. We can make it 5 seconds or 10 seconds. We are making 5 seconds for the time. Now we'll press auto test. Now before testing, we have to put the connector here for the. We have shown this is this spool is a sort of a network for experimenting purpose, and we have put one connection here, green connector, directly on the OTDR port. Now as we put a auto test, touch the auto test button, it is doing the scanning is being done throughout the network by showing this blue ink. It shows the scanning is being done. But it takes some time, and as the scan is complete, there is a graphical representation of the network here with various events. We call the events are the losses that occur in the cable. That shows we call them as events. All event details are being displayed at the bottom of the screen. It shows the graphical representation being presented in the numerical form. The first is the serial number of the event. Since this is 2x3 means is the second event. Then it's the type of the event, whether it is a bending, it's a splice loss, or it's a connector loss. Then the distance in kilometer, then section in kilometer, loss of the event, total loss in dB, and then last is slope in dB per kilometer. I am describing one of the events to explain to you that what is the meaning of each of the event. I will take up the second case, 2x3. 2x3 means second event out of the total 3. This is a Z sign that shows it is a loss in the cable bending. Then it is the distance from the start. Then it is the section in the kilometer. The loss in dB, the total loss because of this bending is 0.2662. Then the total loss means the loss in the bending plus the loss in the fiber cable from the start to this point is 1.4333. Then the slope in dB per kilometer. That shows that this particular event is how far it is there, so that you can take care of the technical problem and solve it by resplicing or by stopping the bending. You can take immediate action. Expert OTDR. This should be used by people who are quite accustomed to the functions of the OTDR and for more accurate measurements. Now I'll press Expert OTDR. Again, the same cable, which is the same fiber cable is connected, which was earlier connected for auto OTDR. Now I will press the average test. Again, the same wavelength is to be taken. I have taken 5 seconds. Here I have to choose the pulse width also. For example, I can use 50 or 100 or even more. The pulse width is to be measured in such a way that if the distance is low, we should go for lower pulse width, and if the distance is more, we should go for higher pulses. So here I am again setting at the old 50 nanoseconds and pressing average test. Now it is going for the scanning of the events. Let's see what the result is. Again, the same events are being displayed. Now they are being displayed with more accuracy. For example, the second event the distance is 1.095. So you can more accurately go to that particular distance to take care of the fault. Similarly, the other events are also being displayed. Thank you. Slicing. It can check for a fiber break, the faults due to bad split.